Hey, so today we're going to talk about nuclear bombs, how they work, and the components involved for how nuclear fission on what is needed for it to occur. So, basically, a fission bomb, it works on the principle that it takes energy to put together a nucleus with many protons and neutrons. Splitting the nucleus up again then releases some of that energy. Some atoms have unstable nuclei, which means that they tend to break apart with little or no nudging. Let's talk about uranium and plutonium. They are radioactive elements. These two elements are very unstable nuclei, which is what causes their radioactivity. When a nucleus breaks into two smaller nuclei, a couple of neutrons shoot out. This is where the radiation occurs. Naturally occurring uranium and plutonium have atoms constantly undergoing radioactive decay. They're spaced sufficiently far apart so that the neutrons rarely bump into one another into other unstable nuclei. However, when a neutron does hit an unstable nucleus, it causes that nucleus to break apart and send out another couple of neutrons. By increasing the concentration of these unstable atoms, the probability that a neutron from one decay causes another one to increase. The concentration where the reaction sustains itself is called critical mass, and the reaction is then called a chain reaction. So with each step of the reaction, energy is released and another step or two is started. And this is an avalanche of reactions, and energy release continues until fissile, the unstable material, is spent. So let's talk about specifically how the nuclear bomb works. And let's start with the uranium. So uranium is a naturally occurring heavy metal. It comes as uranium-238 or 235. Both are radioactive and will decay into other elements given time, but only the latter can be forcibly split when neutrons are fired at it, and this is the basis of a nuclear bomb. When an atom breaks apart, it gives out energy and more neutrons, like I explained before, which then can split other atoms. As I explained before, you get enough of these atoms splitting, and then that's how that chain reaction occurs. And this is how the bomb blast happens. So, natural uranium consists of the isotope 238, which bounces back any neutron striking it, which is completely useless for a bomb. In order to make a bomb, natural uranium needs to be treated to concentrate the 235 isotope within it. And this is basically what you would have to do is for every 25,000 tons of uranium, only 50 tons of metal are produced. That's less than 1% of uranium-235. No standard extraction method will separate the two isotopes because they're chemically identical. So instead, uranium is reacted with fluorine, which is heated until it becomes a gas and then decanted through several thousand fine porous barriers. This partially separates the uranium into two types. One is heavily uranium-235, which is the enriched part, while the rest of it is the depleted uranium, and that's used to make conventional weapons. In order to make a nuclear reactor, you would use uranium that's enriched to 20%. Uranium-235. But for a nuclear bomb, you would need to have uranium that's enriched nearer to 80 or 90%. So you would need to get about 50 kilograms of this enriched uranium in the critical mass, and then you would have a bomb. Any less than that chain reaction would not cause any explosion. So that's just a little bit of how nuclear bombs work. I hope you like it, and thank you. Bye.